For tonight's homework, I'm going to have you copy these 3 problems into your composition notebook and then write a complete sentence about each of the 3. Show me tomorrow. So here we go. That first one there, again, these are both solved for y. So once they're solved for y, all you got to do is look at that first number, the starting point, that 5, that is the y-intercept. That's where you go on the y-axis. Then you look at that number in front of x, which is 2. Made into a fraction is 2 over 1, which means from 5, every time I go over a box, I go up 2, over 1, up 2. Be able to stair step both directions. That line will be a dotted line because that inequality is just a plain old inequality. That is y is less than, so I will shade below my line. So since I'm doing a system here, I'm just going to shade a little bit until I know the exact area. So just shade a little bit of that first line. I'm going to go to the second one. That is solve for y. So again, I'm going to start at -1 on the y-axis. That slope is -2 over 3, which means every time I go over 3, I go down 2. Over 3, down 2. Right 3, down 2. Right 3, down 2. Be able to stair step the opposite direction. That will be a solid line because of my inequality. That is more than, so I will shade above. Excuse me. And then I can see that the shaded area of these 4 parts that those 2 lines make, only this part has the shading areas overlap. So I'm going to double in that in. I'm going to shade that in. Now I'm going to choose any point in this shaded zone to prove that that is the solution to both inequalities. A nice easy one, of course, is this origin 0, 0. Plugging in 0 for x, 0 for y is always the easiest way to go. Plugging in 0 times -2/3 will just give that 0. So here you go. Where y is 0, I plug in 0. Where x is 0, I plug in 0. That 2 and that 5 are still there, part of the original inequality. The second one, 0 for y, 0 for x. Know that that -2/3 times 0 just goes away, cancels into 0. So all it's left is -1. And then both those statements are true. 0 is less than 5 and 0 is greater than -1. If you're forced to plug in a point that is not 0, my suggestion to you is try to get rid of this fraction or pick an x value that has a 3 in it. So when I plug in any value in here that has a 3 or multiples of 3, those 3's will cancel away and just give me a whole number. So again, any number with a 3 for x, like right here, 3, 0, 3, -1, 3, -2, 3, 1, 3, 2. All of those will be good because when you plug in 3 for x, the 3's will cancel away. So here I go. I believe I choose for the hard one. I choose and again, trying to get multiples of 3 in that x coordinate. I'm using 3, 0, I believe. Could have used 3, 1. Could have used 3, 2. Could have used 3, -1. 3, 0 is good again because it has 3 in the x spot, which will cancel away this 3 when I plug it into that second inequality. 0 for y in that first one. 2 times 3, where x used to be, gives me 0 less than 6 plus 5. 0 is less than 11. That's a true statement. When I plug that into the second one, a little bit harder. So 0 greater than or equal to -2/3 times 3, where that x used to be, -1. Over here, I'm going to try to show you what happens when you multiply -2/3 times 3. -2/3 times 3, which is 3 over 1. Any whole number is always over 1. Times fractions by multiplying the top number straight across, bottom number straight across. Gives you -6 over 3, which is -2. So believe it or not, this simplifies into -2. Or some people will cross off those 3's and just bring down that -2, which is left. And then 0 is greater than -2 minus 1, which is -3. That is also a true statement. So my check worked. Second one, these are both solve for y, so I'm going to graph them starting at 1, going over 1 up 3, over 1 up 3. That will be a dotted line because of my inequality. That will be shading above because that is y is more than. So shade above, shade above. The second one, negative 3 is my starting point. Over 2, down 1. That is my slope from negative 1 over 2. Over 2 for my run, down 1 for my rise. That is a dotted line also. That first inequality up on top, that is more than. So when I go back to this 3x plus 1 line, I'm going to shade just a little bit above it. And then I'm going to go to the other line, which is y is less than. So going back to this line, that is a little bit below. And now I can see that this is the only area where the overlapping areas overlap, or the shading areas overlap. So I'm going to fill that in. I'm going to pick any point in this shaded zone. I want to get rid of this 2. So that means any x value in here that has 2 or multiples of 2 will take care of business when I plug that in for x and y. So I could use any 2, 2, negative 3. I could choose negative 4, negative 3, all those multiples of 2 in the x coordinate. I'm going to choose negative 2, negative 3 for x and y. So for that first inequality, I plug in negative 3 for y. I have the greater than inequality. 3 times negative 2 where x used to be, plus 1. Gives me negative 3 greater than negative 6 plus 1. Negative 3 is larger than negative 5. That is a true statement. You'd rather owe someone $3 than owe them $5. So negative 3 is a bigger value. Plug in negative 3 and negative 2 in the x and y in the second inequality. Negative 3 for y. Negative a half right there, part of the original. Negative 2 where x used to be. Over here I'm going to show you what I'm doing. Negative a half times 2. Times negative 2, which is negative 2 over 1. You multiply straight across. Negative 1 times negative 2 over 2 times 1, which gives you positive 2, because negative 1 times negative 2 is positive 2 over 2, which gives me 1. So this cancels away into 1. Or you could cross out those 2's and cross out those negatives if you want, and just be left with that 1 right there. So you get negative 3 less than 1 now. There's a 1 there. Minus 3. That is a true statement because negative 3 is less than negative 2. You would rather owe someone $2 than 3. This is a smaller value. That is true. All right, last one. For these, you need to make sure you solve for y. So that first one is not solve for y. So I'm going to do the opposite of subtracting 2x. I'm going to add 2x. I'm going to bring that y down. That gives me y greater than or equal to 2x plus 1. It has a y-intercept of 1, a slope of 2 over 1. So over 1 up 2, over 1 up 2. That will be a solid line. Be able to stair step both directions. Solid line, more than, will be shaded just a little bit above. Now the next one, negative 4 is my y-intercept, so right here. Negative 1 over 3 is my rate of change or my slope, so over 3 down 1, over 3 down 1. Be able to go both directions. That will be a dotted line that is shaded below. Where the intersection is right here in this quadrant. And again, I need to pick a number that has my x term disappear. So I'm going to pick an x value with multiples of 3 in it. I'm going to choose negative 3, negative 4. I could have chose negative 6, negative 4. I think that's the one I'm going to use. That is in the shaded zone. So negative 6 for x, negative 4 for y. Plug in x and y into both inequalities. I could plug into the original, which I'm going to do here, or the one I solved for y. Negative 2 times negative 6 plus negative 4, where y used to be, gives me 12 minus 4. That's 8. 8 is greater than 1. That is true. So now when I plug in the harder one, negative 4 for y, less than negative 1/3, where x used to be, I plug in negative 6. That's going to give me negative 6 over 3, which turns into just plain old positive 2. I'm going to try to show you. So negative 1/3 times negative 6 over 1, straight across gives me positive 6 over 3, which is 2. So this gives me negative 4, where this used to be, I have a plain old 2 now, minus 4. Gives me negative 4 less than negative 2. That is also a true statement. All right. So good luck. Show those problems in your composition notebook. Again, there's that last one. I'm sorry that got cut off, but that one worked as well. Good luck.